start this, let's go over this. So, as you can all see, you did terrible.
Yeah.
And so we're going to eat up now all the cushion we had in the schedule. The material only gets harder from here. If you guys aren't getting this, you're in trouble for the rest of the semester. It's not magically going to get easier. I'm not going to give you A for effort type points. It's not going to happen. You want to pass the class, you've got to learn this material. There's no way around it. So here's our one reset. We're eating up the 2 weeks that we have as a cushion. And it's gone. I can't do this for you again come the next test. So we're going to consider this a practice test. I'm going to write a new test. It's going to have problems similar to the ones that we have on here. And we're going to do that test next week. Today, we're going to go over and record going over this whole test. And you better know how to do every problem on this test. If there's a problem that you're struggling with, you're not sure how to do it, you're in trouble. We got to figure that out. You got to get help, talk to me, you can text me, email me, whatever. We can help you figure out how to do these problems. You should be able to do all of these. It only gets harder. So we've got to get to the point where this is not a struggle. So let's go over it, make sure everything we go over makes perfect sense. You understand exactly how to do this. So next week when you see a problem like it on the test, there's no question, you got it, we all get A's, and we move forward. Wouldn't that be great?
Yes.
Let's do it. All right. Number one. Probably the most depressing problem on the test. A negative times a negative is?
Positive.
Crazy. Negative 4 times negative 2 is?
8.
Positive 8. Now, when there's no sign there, it's always multiplication.
Right.
So that wasn't plus, that wasn't subtraction, that wasn't division, that was multiplication. Negative 4 times negative 2. I think like one of you guys got that right. Okay, again, negative 3 times negative 9 is?
27.
Positive 27. Positive 4 times negative 6 is?
Negative 24.
Negative 24. Negative 49 divided by negative 7 is?
7.
Positive 7. Negative 16 divided by 2? Negative 8. Just count the number of negative signs, and you almost know exactly what it is. Hey,
I'm starting to see it.
we're missing Lydia.
Is that it?
Yeah,
Thank you.
thank you. All right. So, just multiply the numbers together. If there's 2 negative signs, it's positive. If there's only 1 negative sign, it's negative. Here, divide them, same process. No questions on that. You're ready next time when I give you 5 questions like that. No
Yes.
problem. You're going to get it.
Yes.
Be careful. I might force you to add negative numbers together instead of multiply them. Make sure you know how to add them. Make sure you know how to subtract them. Okay. Problem 2. 1/3 plus negative 4/3. When we add fractions together, first thing we have to do is get a common denominator. They already have a common denominator, right? So we can rewrite this as 1 plus negative 4 all over 3. And 1 plus negative 4 is? Negative 3. If you have $1 and you owe me $4, you're left with being in debt $3. So 1 plus negative 4 is negative 3 over 3. And a negative divided by a positive is?
Negative.
Negative. And it's negative?
1.
Negative 1. Perfect. Okay, next one. If we're adding fractions together, first thing we do is
Find a common denominator.
find a common denominator. What's my common denominator going to be? 20. So I need to multiply this term top and bottom by 4, and this term top and bottom by 5. I can't change my terms. But multiplying a term by the number 1 is okay. You can always multiply by 1. It doesn't change the number. And so I am taking 3/5, and I'm multiplying it by 1. Plus 5/4, and I am multiplying it by 1. So that the denominator of this is going to be 5 times 4, and the denominator of this is going to be 5 times 4. So they're going to have the same denominator. That's the whole point of that process. So what are we left with? 3 times 4 is
12.
12. over 5 times 4 is
20.
20. Plus 5 times 5 is
25.
over
20.
20. Now we have a common denominator, so we can just add them together. 12 plus 25 is 37, all over 20. Okay. Next one. 11/8 minus a half. What's our common denominator going to be?
4 eighths. Negative 4 eighths.
What's our common divisor? Our common denominator? 8, right?
Yes.
Now we could have, you can always just brute force it, multiply this one top and bottom by whatever that is, and multiply this one top and bottom by whatever that is. So I can multiply this by 8 over 8 and multiply that by 2 over 2, if I wanted. Or you can see 8's the common divisor. So we have 11/8 minus 1/2. Now I can multiply it by the number 1, and it doesn't change it. So I'm going to multiply it by 4 over 4. Why am I doing that? I'm trying to get a common divisor. I want them both to be divided by 8. So I multiply each term by 1, the special 1 that I need to get the same divisor. Up here, the special 1 I needed was 4 over 4. The special 1 I needed was 5 over 5. But you're always just multiplying by 1. So, multiplying this one, top and bottom, by 4 over 4, we get, it's still 11 over 8 minus 1 times 4 is,
4.
2 times 4 is
8.
8. So it's 11/8 minus 4/8. If that confuses you, now we have a common divisor. We can write it all as one fraction. We can write this as 11 minus 4 over 8. And 11 minus 4 is
7.
7 over 8. Right?
Yes.
Perfect sense. Okay, next one. 9/7 minus negative 5/3. Subtracting a negative is the same as adding a positive. So first things first, this is the same thing as 9/7 plus 5/3. Right? Now, what do we do? Common divisor. I need to multiply this one top and bottom by
3.
3, and this one top and bottom by
7.
7. So that's exactly what I'm going to do. So this is the same thing as 9 over 7 times 3 over 3 plus 5 over 3 times what?
7 over 7.
7 over 7. Notice how I'm multiplying each number by 1. So it doesn't change the number. Now, just do it. 9 times 3 is? 9 times 3 is? 27. Over 7 times 3 is?
21.
Plus 5 times 7 is?
25.
Over 21. Now we have a common divisor, so we can just add the two numbers together. So 27 plus 35 is? 62. Over 21. Any questions on that one? Okay. Multiplying fractions together. Always way easier than adding them together, because you don't have to find a common divisor. You can just multiply it across. Now what a lot of you guys did is you multiplied the 2 into the denominator and the numerator. But remember, negative 2 is the same thing as negative 2 over 1. So this is the same thing as we're multiplying these two fractions together. Negative 2 over 1 times negative 5/6. And you can think about the negative as always being in the numerator. Negative 2 times negative 5 gives us
10.
positive 10. Good, positive 10. And 1 times 6 gives us 6. 10 6. Now it's an even over an even, so we know we can
Simplify.
reduce it. Yeah. And what does it reduce to? 5/3. Fantastic. There's the answer to that. Any questions on that one? Nice. Next problem. So this one, we just evaluate the numerator and the denominator separately. So here we have negative 9 minus 2 minus 5. We do it in the parentheses first. So this is negative 9 minus, what's 2 minus 5? Negative 3. Fantastic. Still all over negative 6. Okay. Now, negative 9 minus negative 3 is the same thing as negative 9 plus 3. Good. All over negative 6. Negative 9 plus 3 is?
Negative
Negative 6. So we're left with negative 6 over 6,
Which is just 1.
which is just 1. Anytime you have a number over itself, it's just 1. Perfect.
Yeah, I'm realizing
Ah,
half of my things I kept adding a negative sign to it.
good. Let's get it all cleared up now. So next week we can do good. All right. Next one. Notice that's an absolute value symbol.
Yes.
Okay. So let's start evaluating this. Let's do these brackets first. So this is negative 1 minus negative 5. What's that going to be the same as?
Negative.
Writing these brackets.
It's gonna be negative 1 plus 5.
Negative 1 plus 5. So that's those brackets times the absolute value of 3 plus 2 is
5.
5. All right, negative 1 plus 4 is?
It's just
Or sorry,
4.
negative 1 plus 5 is 4. Good. Times absolute value of 5?
It's just 5.
Just 5. 4 times 5 is? And there she blows. All right. Next one. Division sign. This is the same thing as what we have up here. Just writing it as a fraction. So let me just rewrite it before we even try evaluating this. What this is saying is we have negative 7 minus 5 all over negative 2 minus negative 6. Right? That's all that divide means. Same thing as this. And then we just evaluate the top and the bottom separately. Negative 7 minus 5?
2.
Negative 7 minus 5.
Sorry, negative 12.
Minus 12. Good. All right, down here we have negative 2, but let's handle this one first. Minus negative 6 is the same thing as
Plus
Add
6.
adding 6. Good. This is equal to, we have negative 12 all over. Negative 2 minus 2 is negative 2 minus 2 more.
Negative 4.
Negative 4 plus 6,
2.
positive 2. And then this evaluates to
6 over 1, which is 6.
negative 6 over 1. So negative 6.
I see the negative symbol.
Okay. So there's that one. Next one, right here. I'll just come right down right here. So we have 5 times negative 5 plus 6. Huh?
Yeah, it's just 1.
Yeah, negative 5 plus 6 is just 1. Times 6 squared is
36.
36. So we have 36 times 5.
Yes.
Or, one way you might see that easier is it's 5 times, multiplying by 1 doesn't change anything, but 36 is the same as 2 times 18.
Okay.
And so you have 5 times 2 times 18.
Right.
What's 5 times 2?
10.
Times 18?
180.
180. So that's one way to quickly see it was 180. You could have just multiplied it out to see it. You could have done 5 times 6 is 30, 5 times 3 is 150, 30 plus 150 is 180. However you see it. Any questions on that one?
No.
Makes perfect sense. Okay. Next one. So negative 13 minus 2 is
Negative 15.
negative 15. And now we got to evaluate the denominator.
Okay.
So let's write it out. We have 2 minus, let's see, negative 1 cubed is, well, it's negative 1 times negative 1 times negative 1.
Negative 1.
Negative 1. So cubing it, we're left with still just negative 1.
Okay.
Plus negative 6 minus bracket. Here we have negative 1 minus negative 3 is
Just plus 3.
just plus 3. Good. Okay, so that turns into this thing. Okay, so we have negative 15 all over. Let's do what's inside of here first. Negative 1 plus 3 is
2.
2. So we have 2 minus negative 1. Maybe we can fix that while we're at it. So 2 minus negative 1 is
1. Just add it.
plus 1, right? Minus negative 1 is the same thing as just plus 1.
Right.
Then we have plus negative 6. And then we have minus, what do we have in here?
2.
Negative 1 plus 3 is 2. Good. So now this is equal to, we can probably just do it in our heads now. So we have minus 15 in the numerator. Let's see what we have here. We have 2 plus 1 gets us to 3. Minus 6 gets us to
Negative 3.
negative 3. Now minus 2 gets us
Negative 5.
negative 5. There we go. And negative 15 over negative 5 is
3.
positive 3. Any questions on problem 3?
No.
I feel like that's where most of your guys' headache was.
Yeah.
Problem 4. So we have P plus Q minus R times 6 minus P. Where P is equal to 6, Q is equal to 5, R is equal to 5. So start by just rewriting out the expression, plugging in everything. So how much was P? 6. So we have 6 plus Q was 5 minus R was 5 all times 6 minus what was P? 6. All right, 5 minus 5 is 0. 6 minus 6 is 0 times 0 is 0. So we're left with 6 plus 0, which is equal to 6. Good. Next one. I think you almost all got this one, right?
Yes.
If R over 14 is equal to 5 over 14, what's R equal to? Now you can probably obviously see right out the door, just write R is equal to 5. But if we want to do all the steps, if I want to get R by itself, I need to multiply both sides by 14. And so I get 14 times R over 14 is equal to 14 times 5 over 14. 14's cancel out, and we're left with R equals 5. Or you could have just seen it. All right, 6. Here, we're just solving for B. First thing I got to do if I'm trying to get B by itself is, no, we multiply when that term's by itself. First thing I need to do is subtract 7 from both sides. So subtract 7, subtract 7. And what am I left with? B over 3 is equal to what? Huh? 3, right? Okay, now we multiply both sides by 3. So multiply this side by 3, multiply this side by 3. These 3's cancel out, leaving me with just B. And so B is equal to? 9. There it is. Next one. So some of you on this one, you were trying to distribute this negative 4 into here, which you can't do. So it's the negative 6 times that whole thing. It's not the negative 4 times that whole thing. So only the negative 6 distributes in. Negative 4, it's just its own number. So first thing I'm going to do is distribute the negative 7 into this and the negative 6 into this. So negative 7 times x gives me
Negative x.
negative 7x.
Oh, sorry. Yeah, that.
And negative 7 times negative 2 is positive 14. And this is equal to, the negative 4 is just negative 4.
Right.
Negative 6 times x is
6x.
negative 6x. And then
Plus 6.
plus 6. And then some of you added 7x wrong when you added 7x to both sides. So we got to pick which side do we want to get everything on. I think for the most part you guys put x's on that side and your constants over here. So I'm going to do it that way. So I'm going to plus, maybe let's simplify first, sorry. Let's simplify. So negative 7x plus 14 is equal to, over here we have negative 6x. And what's our constant?
Plus 2.
Plus 2. Good. So now we're going to plus 7x to both sides
And minus.
and minus 2 from both sides. Good. Over here, what are we left with?
Is that 14?
12.
Yeah, that's a 14. Yeah, sorry.
We're left with 12.
Yeah, 14 minus 2 is just 12 is equal to, over here we're left with
X.
1x. Some of you got 13x. Okay, so x is equal to 12. Problem 8. Probably your hardest problem on the test, huh? Now we're solving for a. So we have negative a is equal to, I need to distribute this negative 5/4 into this thing. So I need to multiply both these terms by negative 5/4. So negative 5/4 times negative 8/3, maybe let's set it to the side. Negative 5/4 times negative 8/3, what is that going to equal?
You have to get a common denominator.
Not when you're multiplying. We love multiplying fractions. is when you're adding them together, you need a common multiple, or a common denominator. When you're multiplying, you just multiply it right across the board. Think about this. What is 1/2 of 28?
14.
It's 28 over 2. It's 14. You instantly knew 14 in your head. So you can always check, just with sanity checks, you can always think up a sanity check in your own head to see how you do these things. You know when it's 1/2 of 28, 1/2 times 28, you just multiply right across. Or if I ask you for what's 1/3 of 27, you'd come up with 9. That's what you get if you just multiply straight across. So when you have multiplying fractions, we love it. You just multiply the numerators, multiply the denominators. Either put the negatives in the numerator or put them in the denominator, doesn't matter. Pick one. Typically people put in the numerator. So we'll view this as -5 times -8 is positive 40. Good. And some of you got 48, which is where your mistake was. And then 4 times 3 is 12. Okay. And we can reduce if we want. And we can write this as 20 over 6 if we want, or we can write this as 10 over 3. Right? So that's multiplying this to this. So, I don't know why I have an equal sign there. So -5 times -8/3 is positive 10/3. That's how many A's we have. And then -5/4 times 1 is just still -5/4. That's distributing that through. And now this is equal to -19 over 4. Okay, now what do we do? Get a common denominator and add like terms. What's my common denominator going to be for these things?
For the fractions or the just gonna zero.
This is 10/3 A. This is -1A. What's the common divisor of -1 and 10/3? 3. I can view -1, multiply top and bottom by 3. That's the same thing as -3 over 3. If you have -1 pizzas, you have negative. Let's drop the negatives for a second. If you have 1 pizza, that's the same thing as 3/3 of a pizza. If you have 1A, that's the same as 3/3 A. If you have -1A, that's the same thing as -3/3 A. So, this is -3/3 A plus 10/3 A minus 5/4 is equal to -19/4. Okay, now we can add like terms because they have a common denominator. If we've got -3/3 plus 10/3, what are we left with? 7/3 A. So we have 7/3 A. And let's add the 5/4 over here. So this is equal to -19/4 plus 5/4.
Which is 24,
Try again.
Oh, sorry, you're subtracting, that's right.
Yeah.
So,
-19 plus 5 gets us to
It's 6
-14 over 4. Right?
right.
Or, reducing that, we get,
12, -12
try again.
-7 over.
Divide both by 2. Not subtract 2 from both. So we get -7 over 2. Or -7/2. So what do we have so far? We have 7/3 A is equal to -7/2. Now what do we do?
Divide by 7/3.
Divide both sides by 7/3, or multiply both sides by 3/7. Same thing. When you divide by a fraction, that's the same thing as multiplying by its reciprocal. So I'm going to multiply this by 3/7. I'm going to multiply this by 3/7. Over here, what do we get? Just A. That's why we chose that number. The 7's cancel out, the 3's cancel out. Over here, we're left with just A is equal to. Over here, it's just multiplying fractions. We love when it's multiplying. Super easy. Just do the top. -7 times 3 is? -21. 2 times 7 is? 14. And then you can reduce it, or you could have looked at this and saw, okay, 7's go out, and that just gets me to -3/2. If you didn't see that, then just reduce that, and you're going to get back to -3/2. Make sense? Cool. Next one. Here, you're supposed to solve for A. Not X, not C, not whatever else you solve for. Solve for A. Okay, so we're trying to get A by itself. So first thing I need to do is move this term to the other side. So if I subtract bx from both sides, I'm left with ax is equal to c minus bx, right? Pretty simple. Now I'm trying to get the a by itself. So what am I going to do? Divide both sides by x. Divide by x, divide by x. X's go out over here, you're left with a equals c minus b over x. Or sorry, a equals c minus bx all over x. Or, as some of you had it, it's c over x minus b. Same thing. But here's the way it would be more commonly written. But that's perfectly acceptable. Okay, that's 9. Problem 10. I think almost every single one of you just found one solution. When you're dealing with absolute values, there's always and forever 2 solutions. And so, when you do this, you can take your left-hand equation, and you can make it equal to the positive version of what's on the right, and then the negative version of what's on the right. And those are going to give you your 2 solutions. So I can do 5x plus 3 is equal to, take the positive version of this, that's 2x minus 1. And then I can do 5x plus 3 is equal to, and take the negative version of this. The negative version of this is negative 2x plus 1. Don't forget the plus 1. It's not minus 1, it's plus 1. Distribute the negative all the way through. And now you're solving both these equations simultaneously to get your 2 answers. So let's start with our top one. Looking at this, what are we going to do?
We're going to minus 2 from both sides and add minus 3.
You're going to subtract 2x.
Okay, subtract 2x from both sides. Let's start with that. So we're left with 3x plus 3 is equal to negative 1. I subtracted 2x from both sides, so 5x minus 2x is 3x. 2x minus 2x is nothing.
So you subtract 3 from both sides.
Now subtract 3 from both sides, and I'm left with 3x is equal to
4.
negative 4. Yes. And then, what do we do? Divide both sides by 3. 3's go out, you get x is equal to negative 4/3. That's one answer. Now we gotta go get our second answer. It's almost an identical procedure. This time we add 2x to both sides. And we're gonna subtract 3 from both sides. And what do we get? Over here, 5x plus 2x is
3x. Oh, sorry, 7x.
7x. 3 minus 3 is
0.
good. Those cancel out, and we're left with 1 minus 3 is
Negative 2.
negative 2. And so we get x is equal to negative 2 over 7. Now you guys always have enough time on these tests that you can plug the numbers back in to make sure you got it right. So you can always double check a problem like this. Pick x, plug it in, and make sure it works. Let's try that. So I can do 5 times, we're plugging in which one? Negative 4/3, let's do that one. Doesn't matter which one we do. Plus 3, better equal 2 times negative 4/3 minus 1. If we did it right, this better be equal, or we screwed up. Multiplying it out, 5 times negative 4 is, so we have negative 20 over 3 plus 3. Right? And I want to get a common denominator, so rather than calling that 3, I'm going to multiply top and bottom by 3, and I'm going to call it 9/3. Same thing as 3. You with me? And this is equal to, 2 times negative 4 is? Negative 8 over?
6.
No?
Negative 6.
What's my denominator?
1.
It's just 3. You only do the 2 to the numerator.
Yeah, it's 2 over 1.
Yes, because it's the same as 2 over 1. So don't accidentally multiply the 2 to both the numerator and the denominator. Okay, so we have negative 8/3, and we have minus 1, but we want a common denominator. So I'm going to recall that 1 something that has a 3 in the denominator. 3 over 3. Okay, and then let's see what we get. Negative 20 plus 9 is
11.
negative 11 over 3. Better be equal to negative 8 minus 3 is negative 11 over 3. Take the absolute value, we get positive 11/3. Take the absolute value, we get positive 11/3. It worked. What are the odds? And we could go plug in that number, work it out, and we see it works. So you can always check your answers on these ones. Just plug it back in and see if it works. If it gives you something that's not true, if you would have gotten something like the absolute value of negative 7/3 is equal to the absolute value of 1/2, you know you did something wrong. Because your answer isn't making the equation true. So it's only if you actually plug in a correct answer that the equation will work. If you plugged in something that's bad, it won't work. And so you can test to see if you got those ones right. Okay. Next one. Okay. T varies directly as the square of u. Not directly as u, directly as a square of u. So I know right out the door I have a t and I have a square of u. And they vary directly, which means t is equal to some constant times the square of u. That's the information that gives us. Now, I know that when t is 6, u is 3. So when t is 6, u is 3. So 6 is equal to k times 3 squared. Or in other words, 6 is equal to 9k. 3 times 3 is 9. Doesn't matter if I write the 9 first or the k first. Divide both sides by 9. And I get k is equal to 6 over 9, which is the same thing as 2/3. Dividing top and bottom by 3. That's how you get k. Good? Alright. Next one. Reading these problems. Let's read it. A number. So we have a number. We're going to call it x. Plus itself. That means plus x. Plus twice itself. That means plus 2x. Plus 4 times itself. That means plus 4x. Is equal to negative 104. So x plus 2x plus 4x is equal to negative 104. Or in other words, 8x is equal to negative 104. Or in other words, x is equal to negative 13.
That
Good.
makes so much more sense. I was trying to figure out how it does it. I knew I was wrong. I just forgot the other x when I was doing it.
I'm really glad I'm dumb.
Well, does it make sense what I did?
Yes.
Yeah.
Okay, that's the important part. All right, next one. Here's another one that you can always and forever check. The age one. A is now 34 years old. B is 4 years old. So always and forever, A is equal to B's age plus 30. A is 30 years older than B. That's what we get from that. Right? If A is 30 years older than B, in 20 years, is A still 30 years older than B?
Yes.
Yes. If I'm 5 years older than you, in a century, I'm still 5 years older than you. Always and forever, that's how much older than you I will be. So, A is always and forever 30 years older than B. Now, we want to know, in how many years will A be twice as old as B? So I want to know, when will A be equal to 2 times B's age? So here's my 2 equations. 2 equations, 2 unknowns. Solve one for one variable, plug into the other, you're done. So I have A, I have this telling me what A is, this telling me what A is. Doesn't matter which way I do it. I can plug that in up there, or I can plug that in right there. I'm going to plug the 2B in up here. So then I get 2b. Since a is equal to 2b and a is equal to b plus 30, that gives me 2b is equal to b plus 30. Minus b from both sides.
Right, you
B is equal to 30. So when B is 30, then that is when A will be twice his age. In how many years will B be 30? 26 years. In 26 years, B will be 30, and A will be twice B's age. 26 years, how old will A be?
get 60.
In 26 years, A is going to be 60, and B is going to be 30. Is 60 double 30?
Yes.
Then we for sure did it right. So you can always check. You guys give me some answer like 68 years or whatever you give me. Just check. Say, how old will you be in 68 years? How old will you be in 68 years? Is your age double your age? No? Then I did it wrong. You can always go back and check. Make sense?
Yeah.
Okay. Problem 14. A is 60 miles from B. Unfortunately, one of you guys set the picture wrong, which is always sad. When it's just you set the picture wrong to get the problem wrong. So A and B are 60 miles apart. Now, an automobile at A starts for B at a rate of 20 miles per hour. So I've got an automobile here. We'll call automobile A. It's going this way at, I lost the number, 20 miles per hour. We have an automobile here at B going this way at 25 miles per hour. How long will it be before they meet? These things are in a head-on collision. I want to know, when are they going to crash? I don't want to miss the crash. Right? When are they going to meet? When are these two cars going to run into each other? They're driving right at each other. This one's heading at him at 20 miles per hour. This one's going that way at 25 miles per hour. They're 60 miles apart. When are they going to meet? That's what we're looking for. Now, what's the equation, always and forever, we use with problems like this? What? Rate times time equals distance. Rate times time equals distance. So the distance that A travels is equal to the rate of A times the time of A. If I want to calculate, say A stands for Aaron, some guy named Aaron. If I want to calculate how far he went, all I need to know is how fast he's traveling and how long he travels at that speed. If I know Aaron is running 10 miles per hour, and I know he does it for 2 hours, how far did he go? He went 20 miles. He's going 10 miles per hour, and he's running for 2 hours. He runs 20 miles. Rate times time equals distance. So, A's rate times A's time gives us the distance A travels. Similarly, the distance of B is equal to the rate of B times the time of B. Right? Now we're talking about the time it takes until these two cars collide into each other, right? What's the distance that they go if they collide into each other? How far must they have traveled? 60 miles. Did car A travel 60 miles? No. Did car B travel 60 miles?
No, I really didn't know.
It's their total distance together that's 60 miles. So I know that the distance that A travels plus the distance that B travels has to be 60 miles per hour. Right?
Yes.
What is the distance of A? It's A's rate times A's time. So A's rate, the rate of A times the time of A, plus the rate of B times the time of B, has to equal 60. Just substituting in for their distances. Right? Because the distance of A is always a forever, its rate times its time. So I substitute this in for the distance of A, this in for the distance of B. Now we have more given information. What is the rate of A?
10 miles per hour.
20. We know the rate of A and we know the rate of B. So I know 20 times the time that A is driving until it crashes, plus 25 times the time of B until it crashes is equal to 60. Now there's one more thing I know. There's one more piece of information we have. Who was driving longer? Who spent more time driving before they crashed? A? An automobile A starts for B at a rate of 20 miles per hour at the same time that an automobile B starts for A at 25 miles per hour. Who was driving longer?
A.
Who spent more time driving?
B, because you're going faster.
Who spent more time driving?
A.
You drove longer.
Neither.
Drove a longer distance.
Neither! They both head towards each other at the same time, and they crash at the same time. If me and you line up on opposite sides of this room, and on go we charge and collide into each other, who was running longer? We were running for the exact same amount of time. You might cover more distance than me in that time, but the amount of time we're running is identical. So the time of A and the time of B are the same time. So rather than saying the time of A or the time of B, we'll just say time. The time that these guys are going before they crash, because it's the same time for both of them. If I know that they crashed in exactly 20 minutes, then they were both driving for 20 minutes. Right?
Yeah.
Wonderful. And now we've got one equation, one unknown. 20t plus 25t gives us 45t is equal to 60. So t is equal to 60 divided by 45, which is equal to, take 15 out top and bottom, gives us 4/3. And this is in hours. So in 4/3 an hour, they're going to crash. Make sense?
Well, 15 is.
Huh?
Just wondering about
15 goes into both these. Look, this isn't, 15 is a quarter of an hour. Right? So, goes that 4 times, 3 times? Oh, I thought you were wondering. Okay. Any other questions? That makes sense. Can you reproduce it? And if you can't reproduce it, what holds you up? Always and forever we have this. Is that what holds you up? Coming up with these equations to begin with?
Yeah.
Yes, that's what it is.
And always and forever, I would draw a picture. Drawing a picture helps a ton. Try and visualize the problem. See exactly what's going on. Reproduce it in your head the best you can. I don't know what other advice I can give for a problem like that.
It's because what I did is I did too much of it in my head. So,
Yeah, another thing we need to talk about. So on your homework, I tell you I don't care about your work because I'm just collecting your answers. On your test, you guys need to show me your work. Help me help you. Because if you make a small mistake, I don't dock you near as much as when you make a big mistake. And so, if you accidentally just use a minus sign instead of a plus sign, you'll notice that you typically get a -1 point for that.
Yeah.
On the other hand, if the answer is supposed to be 16, and you just write out of the blue 97, I can't give you partial credit for that if this is all you show me. It's like, where'd that come from? I don't know. Sometimes I can kind of figure out where your answer came from. I can play with it a little bit and guess what you were thinking. But sometimes I just have no clue what you were doing, and it's just out of nowhere. So show me your thinking. It helps me to help you. It helps me see what it is that you were thinking, where the mistake was, and then when I cover it like this, I can say, now some of you were thinking this, and here's why that's not right. And I can find the exact point where you messed up in the problem. Rather than just, no, you got it wrong, and I have no clue what you were doing. Okay. Next problem, a graphing problem. You're supposed to sketch the graph and clearly label at least 2 points. Clearly label at least 2 points means I want to see the coordinates of 2 points. I don't want to guess because you put a dot on a picture what the coordinates were supposed to be. If I see something like this, can someone please tell me the coordinates of those points? Neither can I. So don't do that on your paper. Clearly label your coordinates. I don't care if they perfectly match up. Maybe you didn't draw it perfectly. Maybe you meant this to line up with 3. So right, this is what's supposed to be 3 minus 5. Okay, now I know exactly what you were going for. And I don't have to rely so heavily on you taking the time to get all those tick marks perfect or whatever. So give me 2 points clearly labeled when you have to graph, and that way I can quickly check your graph to see if it's right. And I don't have to rely upon you guys drawing these neat pictures, because I know that's obnoxious. So, let's graph this problem. I'll try and draw you a neat picture, because it's obnoxious. Okay, so, this is in what form? The slope intercept form. So this number right here is our slope. This is not the slope. Yes, this is your y-intercept. Now, you guys, you can be so lazy with these problems, it's a little bit painful. You don't even have to internalize and say, what is this giving me? You can just come to the side without even thinking about it and say, when x is 0, what's y? And plug in 0. Oh, -4. And when x is 1, what's y? Or if that confuses you, you're like, what number would make it easy? What number, if I plugged it in for x, would make it easy to figure this out? 4 would be easy, because that just cancels out with the 4. It gets rid of the fraction. So if I plug in 4 for x, what do I get? Well, -5 times 4 just leaves me -5. -5 minus 4 is -9. So that's how I would have done the problem if I were doing this on test. And then just go plot those 2 points and just draw a line right through it. But I'll do it the way I think the author intended you to do it as well. So what does he probably want you to do? Something like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Shouldn't use much that way. And then 2, 3, 4, 5, 6, 7, 8, 9. Okay. So y-intercept is -4. That means we cross a y-axis at -4. 1, 2, 3, 4. Here's a point. Or the same thing as 0, -4 that we got over there. Okay. Now, we know the slope is -5/4. Negative means it's going down. Positive means it's going up. So -5/4 means if we go over 4, we go down 5. That's one way you could have thought about this. So if I go over 4, 1, 2, 3, 4, I go down 5, 1, 2, 3, 4, 5. And then this would have coordinates. What would the coordinates of that be? We went over 4, and we went down 5 more from this. This was already -4. We went down 5 more. That's -9. And so, you see we got that one. Or, I think most of you try going this way. So we could go up 5 and back 4. So we go up 5, 1, 2, 3, 4, 5, and back 4. 1, 2, 3, 4. And now this has coordinates, -4, 1. And then draw the line. I don't care how pretty it looks. But it's obvious to me that you knew what the line was. If you show me those 2 points, or those 2 points, or those 2 points, I don't care. Clearly label some points. Make sense? Okay. Now that was the only one that was asking you to graph. All the other ones you do not need to graph. So this was the only one that you were supposed to graph. So let's move on to this one. Find the slope of the line through these 2 points. Our slope equation, most of you wrote the equation right, you just didn't plug it in right. Our slope is y2 minus y1 over x2 minus x1, where x1 is the x-coordinate of one of the points, and x2 is the x-coordinate of the other point. And y1 is y-coordinate, y2 is another y-coordinate. So we pick one to be our 1 point and our 2 point. We'll call this our 1, this our 2. So this is what we're calling x1, comma, y1. And this is what we're calling x2, comma, y2. So there's an x and a y, an x and a y. It's not x, x, y, y. It's x, y, x, y. And then you just plug it right in. And some of you forgot that when you subtract a negative, you get positive. So let's plug it directly in. What is y2?
-15.
With the way we have it written, it's -15. Minus whatever y1 is. Y1 happens to be 10. If it was a negative, that would be minus a negative. This is over. What's x2? -2. Minus, what's x1? -2. So this is equal to -15 minus 10 is? negative 25, negative 2 minus negative 2
0.
is negative 2 plus 2. So we get negative 25 over 0, which is not a slope of 0. It's a slope of undefined. It's not a line that looks like this. It's a line that looks like this. It goes through negative 210 and negative 215. Negative 210, negative 210 is going to be like right here, and then negative 2, negative 15 is going to be down here. So it's a vertical line like this, not a horizontal one. Okay. So in this case, it's undefined. And you did need the picture. All right. Next one. Write the slope-intercept form of the equation. The slope-intercept form is basically just solve for y. I think almost all of you guys did this one correctly, except for you forgot when you divide a negative by a negative. It's positive.
Yeah.
So we just divide both sides by negative 3, divide by negative 3, just divide everything by negative 3. Right? Negative 3 over negative 3 is 1. 1 times y gives us y. Good. Negative 5 over negative 3 is positive 5/3. So this is 5/3. You can keep the x in the numerator or put it to the side like that. Doesn't matter. And then 9 divided by negative 3 is?
Negative 3.
Negative 3. Yes. There's our answer. So nice and simple. Just solve for the y. Okay. Now, the point slope form of the equation. This is a tough one. This is a big equation to remember. It's y2 minus, thinking about a different one. It's y minus y1 is equal to m times x minus x1. I watched one of you guys had it written both ways and guessed the wrong one.
Yeah, that was me.
So, remember that it's the y's you want by themselves. So, y minus y1 is equal to m times x minus x1. Here's our point that we plug in. Here's our slope. So, this right here is your x1. This right here is your y1. This right here is your m. So, this is literally just y minus negative 5 is plus 5 is equal to 9 times x minus negative 1 is plus 1. And you don't have to mess with it anymore. All you literally have to do is plug it in like that. Now, if you work with it and you solve the equation and get it in y-intercept form, I'm not going to dock you for it. You're just working yourself harder than you need to. This is already done. So you literally just plug in the numbers and just remember that minus and negative is positive. That's no problem. Okay. And then, for the life of me, I cannot figure out how you guys were coming up with your answers on this one.
Yeah, I still don't know.
Okay, so we are looking for a line that goes through this point and is perpendicular to this line. First off, let's wrap our heads around this line. What is the slope of this line? Huh? What's the slope of this line? Just move x to the opposite side really quick, and so you get y is equal to
It's negative 2.
x minus 2. Now you have it in slope-intercept form.
That's the minus.
That's just
The coefficient of x is your slope. What's the coefficient of x?
1.
It's just 1. This is the same thing as 1 times it.
Okay.
Okay.
Now I know how I.
Now I know what I did wrong.
So what is the slope of this line?
1.
1. We are looking for a line whose slope is perpendicular to this and goes through this point. So we know it goes through this point, so basically we know we're using this equation. We're using y minus y1 is equal to m times x minus x1. That's our equation. Now I know my x1 and my y1, here they are. So I know that I have y minus 5 is equal to m times x minus negative 2 gives us plus 2, right? So I know I have this, I just got to figure out what that slope is. So I've got to use this equation to figure out my slope. Now if this line was parallel to this line, my slope would be 1. If it's parallel to this line, they have the same slope. That's what a parallel line is, right? If it's perpendicular to the line, it's the negative reciprocal of the slope. So in this case, our slope is 1 over 1. So if we take the negative reciprocal, flip it over, and make it negative, we get negative 1 over 1. If the slope of this line happened to come out something like 2/3, then the slope of our perpendicular line would be negative 3/2. Flip it, make it negative. That's the slope of the perpendicular. But in this case, it came out to 1, so the negative reciprocal of 1 is just minus 1. And so it's y minus 5 is equal to minus 1 times x plus 2. Now it says get it in the slope intercept form. That's the one where you just solve for y. So let's just solve for y. So distribute the negative 1 through, and so we get y minus 5 is equal to negative x minus 2, right? And then, what's next?
You subtract.
Add 5.
Add 5 to both sides. Subtract negative 5 or add 5. And we're left with y is equal to negative x
Plus 3.
plus 3. Wonderful. And there we go.
Yeah, I did negative. Just an idiot.
And then only one of you even attempted the extra cut problem. And the one of you that attempted it got the problem. So that was great. So let's go over this problem, because it really wasn't that hard of a problem. So an executive drove home at an average speed, or drove from home at an average speed of 40 miles per hour to an airport, where a helicopter was waiting. The executive boarded the helicopter and flew to the corporate office at an average speed of 60 miles per hour. The entire distance was 150 miles. The entire trip took 3 hours. Find the distance from the airport to the corporate office. So we've got, here's home,
We have 40 miles.
here's the office. Oh wait, this is the airport.
Yeah, airport.
And then this is the corporate office.
Right.
I know that this total distance here is 150 miles. I know that going from here to here, he was going at
40 miles
40 miles
per hour.
per hour, and going from here to here, he was going at
60
60 miles
miles per hour.
per hour. So I'm going to call the rate, the time, and the distance that he went here, I'm just going to call the distance d1. So this right here I'm going to call distance d1, and then the distance from here to here I'm going to call distance d2. For the first part of the journey and the second part of the journey. Right? Now always and forever, d1 is equal to r1 times t1, and d2 is equal to r2 times t2. The distance that he travels in the first part of the journey is equal to his rate for the first part of the journey, which happens to be 40, times the time it takes him to do the first part of his journey. And similar for the second part of his journey. The distance he travels for the second part of his journey is equal to the rate he travels for the second part of his journey times the time of his second part of his journey. So we know that always and forever. We know d1 plus d2 is equal to the first distance plus the second distance is equal to 150 miles. And then finally, we know the time of the first part plus the time of the second part is equal to 3 hours. So there's all our information. Oh, we didn't plug in the rate yet. So let's really quick rewrite d1. d1 is equal to 40 times the time of the first part, and d2 is equal to 60 times the time that he went for the second part. So now d1 plus d2 is equal to 150. So d1 plus d2 is equal to 150. So I have this equation, which has two variables, t1 and t2, and I have this equation, which has two variables, t1 and t2. Solve one of your equations, doesn't matter which one, for one of your variables, and substitute it into the other. It's easier to work with this one than with this one. So I'm going to solve this for one of my variables, doesn't matter which one, solve for t1, t2, doesn't matter which one, I'm going to solve for t1. So t1 is equal to 3 minus t2. And I'm just going to plug that in for t1 down here. And then I'll be able to solve for t2. So what do we get? we get 40 times t1, which is 3 minus t2, plus 60 t2 is equal to 150. 40 times 3 is
120.
120. 40 times negative t2 is minus 40 t2, plus 60 t2 is equal to 150. Negative 40 plus 60 is 20, so 20 t2 is equal to, subtract the 120 from both sides, 30. So t2 is equal to 30 over 20, or in other words, it's 3/2 of an hour. So that's how long he spends on the second part of his journey. An hour and a half, or 3/2 of an hour. Now, if the whole trip is 3 hours, and he spent 3/2 of an hour on the second part of his journey, how long did he spend on the first part of his journey? If I've been driving for 3 hours, and it took me an hour and a half to do the second part of my journey, how long did it take me to do the first part of my journey? An hour and a half. 3 minus 3/2 gives us 3/2. So, in other words, I know t1 plus 3/2 is equal to 3. Subtract 3/2 from both sides, and we're left with t1 is equal to 3/2. So t2 equals 3/2, t1 equals 3/2 of an hour. Now I can't remember what we were looking for. Find the distance from the airport to the corporate office.
So from A to.
From
A to.
the airport to the corporate office. So from here to here, what's the distance?
60 miles.
I found the distance from here to here. You got it wrong.
Yeah,
That's the distance from home to the airport.
that's what I was, yeah. I was like, 3/2, what?
Okay, so the distance from the airport to the corporate office,
It's the same.
D2, is equal to R2. What was R2?
R2.
What is the rate he's traveling on the second part? 60. Times, what is the time he travels on the second part?
1/2.
3/2. So multiply it out. Notice that 2 goes into 60 how many times?
30 times.
30 times. So let's cancel that out with that, leaving us with 30. 30 times 3 is 90. So this D2 is 90 miles, and D1 is 60 miles. Because together they're 150. There we go. That's it. That was the whole test.
I think my problem was I couldn't remember the formulas.
On this problem,
for-
I just guessed the answer.
So you need to remember rate times time equals distance is the way you usually say it. Rate times time equals distance.
Yeah.
You need to remember your slope formula. Y2 minus Y1 is equal to X, or X2 minus X1 gives you the slope. Rise over run. You need to remember
Y.
your point slope one. Y minus Y1 is equal to M times X minus X1.
Yeah.
And I think that's it.
The slope is y equals mx plus b.
Oh, you can also remember Y equals MX plus B. That's
The
true.
only one I forgot was rate times
If I
time
would've-
equals distance.
if I would've
That's the only one I
Had
forgot.
all those memorized, I probably would have gotten
4 equations. It's not bad. Right? Okay. So you're going to go home. You're going to ignore your answers, and you're going to look at the homework, the test problems again, and you're going to make sure you know how to solve them all. Then you're going to look at the correct answer and see if you did it right.
Okay.
And if you can do all the problems on that test there in front of you, you'll be fine for the upcoming test. I will base it on these problems. I'll just probably tweak around the numbers some. Or maybe replace some multiplications with some additions and some additions with some multiplications. Stuff like that. But for the most part, it will have the same content. So if there's any problem on there that looks scary to you when you go back and look at it, let's go over it again and make sure it makes sense to you. Is there anyone that scares you? Anyone you don't like?
No, I just
No, they all make
list a
sense.
lot of things.
They all make sense. Love to hear it. They all make sense. And this will be recorded and uploaded, so if you're like, oh shoot, how did he do that again? You can go back and watch it. Good? Okay, so that's that. We'll switch to doing a drill now.